Now that we have a number of derivative rules for inverse trig functions, let's put them into practice here on example 4. Differentiate the following functions. On the first one, we have the reciprocal of the inverse of sine. Totally unfortunate notation, and the reason why is because the reciprocal is often written as a -1 exponent, and then this -1 here is not really an exponent. It's supposed to be the notation for the inverse of that function. Sure, there is a relationship between those two things, but in this case it's totally confusing. So I'm going to rewrite it as 1 over arc sine x. There we go. All right, and now I can either use the quotient rule on this, where I have two functions. Here, one is the top function, arc sine obviously the bottom function, or I can avoid it altogether if I bring this arc sine up to the top with a -1 exponent, arc sine x to the -1. And so here's the reason why I don't care for that, because this one is an exponent and this one's not. Okay, so now I'll have to use the chain rule to take the derivative of this thing, because we have a function inside of a function, right? Okay, so I'll just do this right down here. So I have enough room. Y prime is equal to, leapfrog that -1 down, or just, the negative sign, arc sine x to the -2 power after I subtract 1 from it. Now you have to multiply it times the derivative with respect to x of the interior function, arc sine x, which we just came up with. The derivative of arc sine is 1 over the square root of 1 minus x squared. Yes. Okay, so let's just rewrite stuff. Y prime is equal to negative arc sine x to the -2 power, and then multiply it times 1 over the square root of 1 minus x squared. Yes. All right, and then, we don't like to have negative exponents here, so this needs to come back down to the bottom. We can put that negative up here at the top, make this look real pretty. Y prime is equal to a -1 over arc sine x quantity squared, and then over the square root of 1 minus x squared. Lovely. There you go. Probably it was obvious from the get-go what that one was going to be, right? Likewise, on number 2, here we're going to find the derivative of f of x is equal to x times arc tangent of the square root of x. Okay, so here, notice we have a product of two functions, which means we'll have to use the product rule on it. Product rule. All right, and then on the arctangent part, we have a function inside of a function. We have a composite function. We'll have to use a chain rule on it. F prime of x is equal to, I don't think I'm going to have enough room. Let me just rewrite this guy right down here. So number 2, it was f of x is equal to x arctangent square root x. Okay, use the product rule. Derivative of the first is 1 times the second one, arctangent square root x, plus the first one, x, times the derivative of the second one. What is the derivative of arctangent of stuff? It's 1 over 1 plus our function, whatever it is, our u here, squared. But since we have a derivative, since we have a composite function, I need to now multiply it times the derivative of the interior. So I'm going to multiply that times d dx of the square root of x. Right? And of course, you don't have to keep writing this kind of thing down like I did here, like I did here. You could just do it, right? Where it comes in handy is whenever you have multiple functions inside of multiple functions, where you have to do the chain rule multiple times, like 3 or 4 times. It happens. Anyway, so does copying and pasting. You know what I'm saying? All right, so let's... Oops. Try that again. Instead of hitting delete, maybe I should hit duplicate. There we go. All right, and then the derivative of that guy, we want to think of it as x to the 1/2 power, of course. Leapfrog that 1/2 down, x to the -1/2 power. All right, now... as far as this goes, this is going to stay where it's at. This x is going to come up to the top. This 2 will go down to the bottom here. The square root x will come down to the bottom, and then I can square this square root. A little bit of algebra. So x will come up top, over, and then 2 square root of x, and in the parentheses here, I would write this as 1 plus square root of x squared is x. Okay, and maybe there's one more thing that could be done to this. Let's see. I could rewrite this back here as x to the 1/2 power, and this is to the 2/2 power, so you could subtract those two things if you wanted to, and then rewrite this one more time. That's a square root of x, by the way, as the square root of x over 2 times 1 plus x. That would be roughly exactly equivalent. All right, box something. Box one of these. There we go. I'm going to box them both.